All right. Some time ago, when we spoke about the cursor for loop, I said to you to take a leap of faith, remember? And just work the cursor, understand how the cursor for loop works, which is fairly basic. Don't worry what the system's doing. The system is doing it all for you. And I said there'll be a lecture later on. Well, later on is here, and we're going to talk about manual operation of cursors. Now, I don't want you to do this. You feel free if you want to, but there's no need. But the reason that I'll be teaching you this method, or what's happening with manual manipulation of cursors, is there's going to be millions and millions and millions of lines of code using this methodology, and it doesn't hurt to understand it. Things have moved on. The Oracle developers have created a cursor for loop, which does a lot of the manual, tedious management of cursors for you. Right? So we're going to learn what they used to do, or what we used to do, but you keep using the cursor for loop. And later on, we're going to talk about what collections of PLSQL tables, which is more, shall we put it under the umbrella of advanced data types. Yeah? And as a programmer or as a developer, you really have to understand the more advanced data types of whatever language is your chosen programming language. Yeah? But in PLSQL, I'll show you collections, I'll show you types and records and so on. So we'll talk about the difference between an explicit and an implicit cursor. Defining a cursor, opening a cursor, and fetching a row from a cursor, closing the cursor, and then the cursor attributes and cursors with parameters. So explicit and implicit cursor, very good exam question. A cursor is a pointer to the current set of records. I could never verify whether this is true. What does cursors, what does cursor stand for? And to the best of my information, it's the current set of records. That's basically what a cursor is. Now, a cursor is a pointer to the current set of records that are a result of a SQL query against a database table or tables. Implicit cursor, a cursor that is defined for you by the system. When we issue the statement, select something, something, something into, so basically a fixed SQL statement, that is an implicit cursor. Any SQL, DML, data manipulation language where it's update table, delete from table, select, etc., implicit cursor. The system creates a cursor for you. You don't have to verify, you don't have to define it. You simply issue a valid SQL statement, and the system will create an implicit cursor for you behind the scenes. You don't see it, you don't manage it, you don't operate it. An explicit cursor, when you declare a query in the declaration section of a block, you create an explicit cursor. You will generally use an explicit cursor when you work with multiple records. A single record, when you expect a single record, you will generally use an implicit cursor with a select into, or you need to define something like say a file name or something like that, generally using it from Joule and maybe just one record from a table. Implicit cursor, explicit cursor, when you have a need to process multiple records, and we define a cursor. Managing cursors. Now what happens in a cursor? You define a cursor, you open up a cursor, you loop around, you fetch a cursor. With the terminology is fetch a cursor, not fetch from a cursor. You fetch a cursor, repeat the fetch until there is no more data, and then close the cursor. That's the process. Declaring a cursor. As we've seen in our code up to now, declare under the declare keyword, or in a procedure or function just underneath the create, the procedure or function, you define a keyword cursor, give it a name, and you write as complex a SQL statement as you think is appropriate. And again, I've been sort of harping at you guys that, look, what you're trying to avoid is these hits to the database. Put as much logic as you possibly can into your SQL statement, your initial SQL statement. And one of the tutorials, I forget which one, the one where we had to work out whether we're profitable on a weekend or not, I gave you 3 different solutions. And what I try to illustrate to you was that, look, you can loop around through a cursor, you can do all this, or you can do it all in one go, which is solution 1 to solution 3. And a lot of you, I'm suffering, sorry guys. Maybe a lot of you have come up with other solutions apart from my 3. That could be better. I haven't seen anything online, but so nobody's shared. You are advised to name the cursor as C, whatever the name is, by using the C underscore in the beginning of the name. It will always be clear. So again, this is the self-documenting, referencing convention of your variable and object naming. This is an example of cursor such and such is, and select blah, 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 and make it as complicated as you like. Cursor names follow the same rules of scope and visibility that apply to other identifiers or variables. So you define a cursor in a procedure, the visibility is in that procedure. You define a cursor at the package level, at the package body level, the scope of it is that whole package, that every module inside the package can see the cursor. You define the cursor in the specification, then it's visible outside. Not that you would do it, well, you never know. Somebody might. So again, the scope is the same as any other identifiers. Cursors must be defined before they can be used. Any valid SQL statement can be used to define a cursor. One of the exercises, I just had a thought while I'm talking to you. One of the things that I've never asked people to do is to, we have a cursor that's a select statement. It'd be interesting to see what happens if you start doing things like delete or update a particular record with some parameters and so on, and how the cursor would work. The next, once you define a cursor, the next step is to open the cursor. So the definition of the cursor is basically in the declare section of a block. As you know, you don't have the keyword declare in a procedure or function, but just pretend that declare is procedure function. So in that declaration area, that's where the cursor is defined. And if you create sub-blocks within a block, you can always define a cursor in that sub-block, but still in a declaration area. Next step is the instruction in a block somewhere within a main block is you open the cursor. So here you define a SQL statement, and the SQL statement is the source of your data. Next point is you open the cursor. The variables in a where clause. So when you open the cursor, the variables in a where clause are examined. The active set is determined and the PLSQL engine executes the query for that cursor. In your code, if you could see the stepping of the code, where you declare the cursor, all that the compiler does is checks the syntax of the language. In other words, are you using the right tables? Have you got any spelling mistakes? Did you spell select right? And whatever. That's all that the compiler checks. At this point where we open the cursor, that is the point where the SQL statement is executed, not where you declare the cursor. So the compiler will check the syntax of your SQL statement. In the open clause there, you could see, depending on how much data and how long the SQL statement takes, this is where you'll see your code hesitate and stop while the execution is occurring and the data is brought into the record, into the memory set. So often if you have a very complex query that takes a long time, if it manually takes a long time, then its execution will take a long time when it's running in a program. This may very well slow your program down while the data is being retrieved. And this is often, we'll talk about this in performance tuning and so on, this is often one of the bugbears or one of the problems for slow code, as well as multiple hits to the database. But, depending on how complex the query is and how many table joins you have, your program all of a sudden might take 10 minutes because that's how long the SQL statement takes to retrieve data. The engine identifies and retrieves the active set of data that meets the where conditions, and the active set pointer is set to the first row. So we declare the cursor, we open the cursor, and then we fetch from the cursor. After the cursor has been declared and open, you can then retrieve data from the cursor. The process of getting the data from the cursor is referred to, so you'll hear the terminology, you're fetching the cursor, fetching the cursor. There are two methods: fetch cursor name into a variable or fetch cursor into a record. And I'll talk about that. I've spoken about it before, but I'll certainly talk about it tonight. What is this record? And I refer to the type percentage record type, remember? When a cursor is fetched, the following occurs. The fetch command is used to retrieve one row at a time from the active set. This is generally done inside a loop. After each fetch, the active set pointer is moved forward to the next row. The process continues until the entire set is returned. The last fetch will not assign values to the output variables. This is important. The last fetch will not assign values to the output variables. They will have the previous values. So it depends on how you run your loop, whether you have one extra loop counter or one less, depends, like loop until or loop while. This potentially is an area of danger. The last fetch will not assign values to the output variables. The output variables will still contain prior values. So that's something to watch. So that's all the words, and this is a little bit of code that goes through and explains what's going on. And remember, tonight's lecture is about manually defining and working the cursor. You guys have been using, and please continue to use, the cursor for loop. And all this happens for you automatically. Yeah, for cursor, record in cursor. Basically keep looping around, and what happens? What we're talking about is the manual method of working the cursor, so you have some understanding of what's going on inside the cursor for loop. So here we are. We have the declare cursor, etc., 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 whatever the SQL statement is. Now, I've got this thing commented out, these variables, but what I want to do is but I'll be talking about this record, but here I have variables that are individual variables. And what I'm doing is I need to set up the variables to match the select attributes in my cursor. I have 4 attributes here. So I've taken 2 approaches. One approach I've commented out, but I could comment this out and open this out. So if I have a select statement in my cursor, the select attributes that I have, they need a position to go into. So whether I use individual variables or whether I use this row type. Remember, we spoke about percentage type and percentage row type. But when I spoke about the percentage row type last time, I spoke about a variable and then I used a table percentage row type. So whatever the table was, and the whole idea is that I create a record that contains all the attributes of that table rather than individual variables. So here we're sort of showing you that the record R1 is bound to a cursor, not a table, but a cursor with a percentage row type. So this is my declaration. I have a variable or variables to receive the data that's being processed. Begin, open C1. So we're opening the cursor. Step 1, define. Step 2, define variables to hold the data coming from the cursor. We open the cursor, we put it into a loop, or we put the system into a loop, and we fetch C1 into R1, which is the row type, or alternatively, fetch C1 into V customer number, comma, V customer first name, comma, V customer last name, comma, V customer balance. I prefer to use this method because it's cleaner, tidier, and definitely more sexier. And again, exit when C1 not found. The thing is that this may very well be redundant because what we're saying is keep looping, and this thing will loop from the first record to the last record because we're having the fetch statement. So we're going looping around. Open first of all, then we fetch, and then here I'm saying exit when not found, which is redundant because this loop will go for as long as there are no records. But I suspect, and I forgot why I put this thing here, but I suspect this is to cater for that last record that the system loops around, and when it does a fetch, and the last record that's not really there, it's to avoid that. But again, I suspect this is a redundant statement because this loop will loop around. We could exit when something else happens, when customer number is such and such, which I think we had in a previous tutorial or whatever. And then I simply print what the record is. And then when we finish, after the loop, we close the cursor. Close C1. So we've defined the cursor, we define variables that are going to hold the cursor, we loop around, So when we do an open C1, the system executes the SQL statement, it goes away, bzzz, comes back, and it fills the memory location, and the cursor pointer is pointing to the first record. We basically do a fetch, so that what happens is the system takes the variables, so it puts the cursor data and stores them into variables, whether we do a row type or whether we do individual variables, store them into the variables, we do whatever we need to do, and then we go along and fetch. So basically the pointer is pointing. Lachlan, sorry for a moment. Man, I didn't forget your email, but I lost it.
What email?
Yes, you sent me an email, didn't you? You're going for a tutor's position.
Oh, yeah.
Mate, I didn't forget, but I just lost your email.
Oh, thank you.
I'll see you later. Beg your pardon. So, we're fetching, and at the end we close. And again, this assumes a perfect world. Consider what would happen if an exception gets thrown. Because we have a resource which is a pointer to a cursor, and if an exception gets thrown in here somewhere, control would pass somewhere else. This closed C1 would potentially be bypassed in the exception handler. We want to capture the exception, do whatever we have to do depending on the exception, and if appropriate, close the cursor there or close that pointer. Because what we don't want to do is we don't want all the resources being utilized by trivial nonsense. And the big selling thing of Java is that it's automatic garbage collection. Well, tools like this don't have automatic garbage collection, so these resources would be used up. So this is an example of how the manual operation of a cursor performs. This is what we used to have to do. Now you have your cursor for loop. And most, apart from your definition of your SQL statement or your cursor, everything else happens for you automatically. In your for R1 in C1, and you loop, whatever you're doing, there was no need to open the cursor, there's no need to fetch it, and there's certainly no need to close it. Because what the system does is the system does all that work for you automatically. But like I said, I repeat myself, there'll be millions and millions and millions of lines of code out there for many more years where you'll see this sort of operation happening all the time. Defining a cursor, opening a cursor, loop, and then fetching the cursor, and at some point closing the cursor. And the things to note is, one is fetch, closing at the end, what happens if there's an exception, and so on and so on. Now when we talk about a cursor, in this case C1 is the name of the cursor, which was defined over here, which is linked to a SQL statement. Those cursors have an attribute, and this is the same for your cursor for loop. So percentage not found, so I would say C1 dot percentage not found, a Boolean attribute that returns true if the previous fetch did not return a row, and false if it did, and so on. So you got percentage found, row count. You can always ask before you start looping how many rows are in a cursor and is open. So depending on your logic flow and so on, you might be closing the cursor and doing whatnot. You've got these variable operators and, numeric operators that gives you some ways of interrogating your cursor to, see what's going on and what happened. You don't assume that you're always going to get records out of your select statement. And if not, what do you do? So you've got some attributes that you can check. And again, is open is something, you check, is the cursor still open, or did I close it, or depending on what branch in your code you take, it's potentially, you might have already closed the cursor to open something else and so on. Cursors with parameters. And this is the same for your cursor for loop as well, by the way. A cursor can take parameters which can appear in the associated query wherever constants can appear. A formal parameter of a cursor must be in. Remember when we spoke about parameters before? They could be in, they could be in, out, or they could be out. Passed by value, passed by reference. In a cursor, it's only in. Therefore, they cannot return values to the actual parameters. Why cursor parameters? Look, I'm not going to read the code. I'm not going to read the lecture slides. You can read for yourself. But it makes it more reusable and avoids scoping problems. When you should you parameterize a cursor, you'll know when you're writing code, and if you're writing a cursor, if you find yourself you're writing 2 or 3 or 4 SQL statements, or you're defining cursors, and there's just a slight little difference between the code, potentially you could just write a single cursor and take a parameter, and then that code, you could potentially make a little bit more versatile. So here is an example. Cursor C orders is cursor order line, and then basically the way that you use the parameters is exactly the same as you do in procedures and functions. You can put it as many parameters as you like. P order ID, select, So what I'm showing you there is how to define a parameter. And again, you need its name and its data type. And again, with varchar 2, you don't need to specify the size of it, but everything else is the same: number, boolean, date, etc., etc. We are using the parameter inside the select statement there, and we're also using the parameter in the where clause. So you see this P order ID and P order ID. It's in the same area. Again, could I just point out my poor naming convention? Because I'm using the P underscore, which is the same as I use in functions and procedures. So how would I distinguish a cursor parameter from a procedure parameter? Well, maybe I should have put in CP underscore whatever. But that's only Laurie's little hang up about life and programming and so on, but I'd like to bring it to your attention. And what we're doing is here, it's an example of how we're looking at the order table, and then we're looking at another loop, which is the order line table, and we're processing this cursor, and so we're going through the orders table, then we're going through the order line table, and the value that comes in from the outer loop is being used in a SQL statement for the inner loop. This is a trivial example, and this is too trivial, but there are some circumstances where, depending on how many loops you have, or how many inner loops, where the inner loop query depends on some values that are being processed from the outer loop. And rather than write multiple SQL statements or multiple cursors, you can potentially write a cursor and just pass the parameter to it and then execute the query and give yourself a little bit of versatility. You can use as many parameters as you like. The cursor is called with a list of parameter values. Parameters can be used anywhere in a select statement. Scope of the cursor parameter is the cursor only. So you can't use it, in your DBMS print statement or whatnot, unless you print in the cursor variable. And the mode of the cursor parameter can only be in. That's it. Cursors are the heart and soul. Now, I've asked this question before. Any SQL Server developers here? Microsoft SQL Server. They cringe when we speak about cursors. Yeah, but in Oracle, cursors are the heart and soul of PLSQL. As a database programmer, you must understand cursors no matter what environment you work with. SQL Server, Sybase, Oracle, PostgreSQL, and whatever database you have, MD2 or whatever they are. Previously, I showed you how to use the cursor for loop. where all the procedures are automatically performed for you. You should now have a better understanding as to what's going on. Which you choose to use, it's entirely up to you. I don't really mind, but you'd be silly to sort of manage the cursor yourself. But, some people like that. So that's the cursors. Manual cursors. Yeah, but for you guys, cursor for loop is fine, where the system is basically defining all that stuff for you. And remember, the only thing with a cursor for loop, you say for, then you define a record in cursor. That record that you're defining doesn't have to be defined in the package declaration area, and the scope of that record is only the cursor for loop. Okie dokie, done. Now, take 2. You want a break? You happy? I'm not boring you too much, am I? And I'm recording, so we can't have too much of a break. All right, we're going to talk about records, but what I'm going to do is I'm going to lead to collections. And for want of a better name, this is the closest thing I can get to is we're going to talk about what's equivalent to arrays. Yeah? Or I prefer to call it a complex data types. So we're going to talk about records first, and then I'm going to show you collections. And then I'm going to talk about V-arrays and arrays, V-arrays and collections. And I'm also going to talk about sparse and dense. So there's some terminology that I'll be talking, and hopefully when you walk away, I'll explain all those. I don't care if you use this in your code or not. I would probably leave well enough alone and don't confuse yourself. But one of the things that I do say somewhere in my slides, probably at the end, is that as a good developer, you will do yourself a great service if you study your language of choice and develop a very good understanding in complex data types. Whether they're arrays or whether they're collections or pointers in C and so on, you would be well served to understand variables and how to store data above the normal, this is my name, this is a surname, and so and so. Because what it does is it enables you to create tight code. Arguably, but we'll see. We'll see how we go. We're going to talk about records first, so that there's no confusion, and then I'm going to go from records into collections. In the past, I see people getting mixed up. Oh, why did all of a sudden there's a switch from records to collections? So I'm going to stop and I'm going to say to you later on, okay, we're finished now with records. We're now going into collections. But we use the records to create collections, if that makes sense. And again, from the book, a record is a group of related data items stored in fields, each with its own name and data type. This is a definition of a table, if you like. Suppose you have various data about an employee, such as name, salary, and hire date. These items are logically related but dissimilar in type. A record containing a field for each item, lets you treat the data as one unit rather than 5 variables: customer ID, customer first name, customer last name, customer address, and so on. So you treat it as one unit, which is very handy because you can then pass that backwards and forwards and act on that one unit. Thus, records make it easier to organize and represent information. Remember the attribute row type. We've already used records. We've already been introduced to records in a form of row type. And up to now, I showed you row types with tables. So we create a variable of a table percentage row type and with a cursor percentage row type. So 2 definitions. Table is fixed depending on what the table is. Cursor could depend on your select statement of the attributes and so on. An attribute row lets you declare a record that represents a row in a database table. However, with row type, you cannot specify the data types of the fields in a record or declare additional fields of your own. The programmer-defined record lifts these restrictions and lets you define your own records. Very exciting. Benefits of using records. Again, you can read this at your leisure, but it's data abstraction. Very important. Not important, but you're abstracting. You're talking about a customer rather than individual fields. Your aggregation operation, which is limited. It's of limited value, but it gives you leaner, cleaner code. I think it gives you leaner, cleaner code. Declaring records. Now, we spoke about this already. If we declare a record of an employee table percentage row type, you can see that we have one variable, or let's call it a record type variable, that has a number of fields based on the employee table. The second one, as I said, we have a cursor, and the cursor in the select statement has 1, 2, 3, 4 attributes. 4 out of the employee table. So here we would have every attribute in the employee table. And then we declare a variable of a record type by using the cursor row type. Sorry, somebody's throwing me off. Somebody's talking over there. Sorry. You're just throwing me off. Not that I'm mine, but you're just throwing me off. I'm sorry. Cursor C, so there's your cursor, and then we create a record, a variable of a record type, which is bound to this cursor row type. And these are handy because if we're doing a select into, we don't need to list the fields here. We just say select into and create it into the record. Likewise with the cursor, when we do a fetch, or we sort of turn around and talk about define a record in a cursor for loop, we can then bind the select statement to the attributes of your record. So that's the two that we were already familiar with. I think we've used it certainly in the tutorials. I don't know if you use it in your little exercises and whatnot. Now we're talking about a user-defined record. The key word here is type. So in our declaration section, and this often happens in your packages, often happens either in your body or in the spec. And if you remember from last week when I showed you the UTL file, remember I showed you the specification for UTL file? There was a record type defined in a header, which was the pointer UTL file. And UTL file underscore file type was a type of a record with a number of attributes. And then when we use it, basically we are using this type. So to create your own record, you basically use the keyword type, and you give it a name, and you tell the system that is record. So type name is record. We are creating our own record in brackets, comma separated. We define the attributes of this record. Shall I use the term variable? Type record? But these are variables of this record. So this would be there's your variable. And you are you're defining a type first, which is a record, and then you're creating or you're allocating attributes to that type. Inside that type, we are using the keyword type. So department number. So from the department table, attribute department number type. Varchar, Boolean, date, whatever you're used to so far, you can create as much as you like. And you can create a record as big as you like with as many attributes as you need. Once you've created the type, then you can use it in a definition of a variable. So V underscore department underscore record is of a type department record, this. So we are creating a type, and now we can create our own variable of this type anywhere in our code. If in a spec of our package we create this type, somewhere in our code elsewhere we can refer to that type to define our variables. And this is now handy because if the scope of that type is visible between a number of procedures or functions, you can now pass data backwards and forwards to procedures or functions as one lump chunk rather than individual variables. That's the benefits of records. You're basically grouping data types of an object, let's say a customer or whatever, together, and then you're passing that backwards and forwards. The restraint is the scope of, first of all, the scope of the type, but with packages and procedures we can create types in our specs. So we might have a standard spec and create multiple types for our organizations, our tables and so on, and then basically create variables of that type. And also in our parameter table of our procedures or functions, the type of data that we take in could be of this type. So a variable is defined, we populate it with data, then we create procedures or functions elsewhere, and we pass that record across into the procedure or function as a chunk. Yeah? So very, very handy. This is a diagrammatic representation of what this record looks like. This is the name. We refer to it, but to refer to individual attribute within that record, this record, these are the individual attributes. It's the dot notation. V department rec dot department ID, V department rec dot department lock, and so on and so on. So we treat it, we pass it backwards and forwards by its name, but to access individual fields, it's the dot notation. Very simple and very straightforward, and everything is no different to what we've been using so far. Procedure. So here's an example working with records. Regardless of how you define a record, you work with the resulting record the same way. You can work with the data at the record level or with the individual fields. This includes the return data types from functions. So here's a procedure, raise salary. So somewhere else I have this type defined as a record. And then now in my procedure, I'm accepting a variable or parameter in as a type of this record type. So even though I'm referring to it just by its name, but there are multiple attributes that are being passed into this procedure. And when I call it somewhere else, I will be calling raise salary, brackets, and then I will be passing whatever variable I have, which is of this type. Yeah? So you can see now we're sort of grouping things together. And you're treating it exactly like a variable, except it's much, 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 much more versatile. Record level operation. When we talk about record level operations, that basically you can set all the fields to null in one go. You just say record, at whatever the record is equal to null, and you can set values to 0 or whatever. Like this is let's say we were doing a GPS system, or what's that discipline? Like say CAD systems or mapping systems, where we have a point. Type is a point, and usually on the Earth's surface, a point is marked by X, Y, Z, or northing, eastings, and height, and whatever. You can generally set the values to null or to some value in one operation, rather than saying X dot something is equal to null, Y dot something is null. So record level operations, it means that, but there's little more that you can do with it. You can define and pass the record as an argument in a parameter list. You can return a record back through the interface of a function. So when you start talking about records and you're calling procedures and functions, passed by reference, also the out parameters, you can create record of types. You can create variables of types records, if you know what I mean. Now this is me doing the same thing different ways. So I have a cursor here. I have a record. I have a variable which I'm using of employee row type. Yeah. So you know that this variable will have multiple fields. Here's the table, I believe, of the employee. This is the employee table there. Yeah. I have a cursor which is select star from employee. Yeah. And then I declare a variable which is of the cursor type, percentage row type. So this and this will be the same. Yeah? And now I'm creating a type which is a record, a type of a record, and in there I'm manually listing the attributes of the employee table. And I'm defining a variable of this type. So you can see these three things are exactly the same. Here I'm using row type on a cursor, but I have to define a cursor. Here I'm using a row type of a record, and here I'm creating my own type and I'm using a keyword type, and I define a variable of this type. The benefit here, and to some degree here also, but certainly here, is I can add additional fields in there. But if I add additional fields, and if I'm using a cursor record or try to blend this record with this record, it's a little bit difficult, because then how will the system know which fields to blend if I have additional fields, if you know what I mean. I just had a thought. Can I just go back here at the risk of confusing you? And I hope I don't confuse you. On this slide here, when I'm creating a record, I'm creating a type, which is a record, and I'm listing attributes. In this definition, I can also then create another element which is of a row type. Does that make sense? So I could have a field here. So let's say department record is record, and I put down whatever stuff in here, and then I could have another field in here which could be of, let's say, employee percentage row type. So inside a record, I have another record. And so you think of it as a 2D picture of a record where, you know, we have the fields and we have data in there. Then all of a sudden you're putting depth on it, because you're then creating another row type onto the record, if you know, if I'm making myself clear. And multiple operations of those. So you can build record data types that are, you know, like an atom, a uranium atom, where it's all like that, waiting for a proton to smash it. You can create a data type that's, you know, 2D, then 3D, then, I don't know, what is it, 4D after that, and you can a lot of depth.
That can be recorded, what you just did.
I'm not sure about the arm movements. So yeah, here I showed you the type, but by no means is it limited just to type. You can also create an element of a row type, if you know what I mean. Again, it's a little bit of a problem. You could put a cursor in there and create it of the cursor row type, but then you're binding your data type to something which is, you know, very specific to a bit of code. I digress. So here, there's an example of, you know, the creating records 1, 2, 3 ways, and it's all exactly the same. But the purpose of this slide is to show you that I have 3 records here, and then what I can do is I can say this record is equal to this record. This record is equal to this record. So I'm making one record equal another record. So I'm not having saying these are the elements that are equal to each other. You're doing operations at the record level. Something is equal to something, and the system will basically bind those values together in the order that they appear. Very, 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 very sexy way of programming. One of my examples that I gave you, I think it was on lecture 1 or lecture 2, which was the Snowy Benefit Cap, SBC. I gave you a bit of code where I use records and collections. Might be, you know, if you're interested, go back and have another look at that sample that I gave you, and you'll see how I use this stuff. Before it was probably confusing for you. Anyway, record level operations, what do we do? Fetching a cursor, open a cursor, fetch the cursor into the record. So we've learned about fetch just a little while ago. So we're fetching the cursor into the record because somewhere this record is defined in the previous slides. Make a procedure call, and I'm calling a procedure update employee commission, and I'm passing the record to that procedure. That procedure, the definition is here, and then when I define it, I'm defining it as an employee percentage row type. You see that? I'm creating a procedure. My parameter is of a row type, and when I call the procedure here, it's binding into this parameter. And then what I do is I, play with all the stuff over here, and then I'm returning a record back to the caller. Return. Oh, that's a function. That's a procedure. I don't know. Oh yeah, sorry. This is the function. up that employee. So, there's a record here. This one returns a record. I'm passing a record in, and the system is returning a record back. And we potentially might change some values in there, and those values could potentially be reflected in the main code. So you can see you can really abstract your code and make it look, the developer understands it, but this sort of code is when young developers come in from uni onto a workplace and they say, Laurie, would you just have a look at this code? We need to tidy something up or need to make some changes. When you come across code like this, unless you understand what's happening, unless you have a handle of where to start looking at it, it could be very abstract. The word is abstract. We're abstracting a code deliberately, but you have to be a fairly high-level developer to start understanding how best to utilize it and how to read it. But, frankly, you will be very, very wise to learn this stuff and understand how it all works and what it's all about. And really, it's not all that complex. The system is doing all the complex work. You just need to understand it. So that's the records, end of records. We're now going to talk about collections, but in the collections we will be using records. And what is a collection? So, record is fine. You can use that in your code now if you like. No problems. The problem, not the problem. The limitation of records is that it's a single dimension thing. You're creating one element of an employee table, yeah? So you still need a cursor or something to traverse through, and you're storing one record of an employee into a variable. Even though it has multiple attributes in there, but you're still only storing one record. When we start talking about collections now, what we're talking about now is that we will now create, in your mind, think array, but I'm referring to collections. Right? Collections are different to arrays, but I'll explain what. And if we want to take our, let's say, employee data, we bring it across and we populate the array or our memory location with all the data that we need from a cursor or whatever. Now, you might think to yourself, yeah, but I can do that with a cursor. I can get all the data from the employee table and I can bring it in through a cursor and I can process the cursor. True. But with a cursor, you can't go backwards and forwards in your data. You can only go through down and process the data. With the collections, what I'll be showing you is how we can load our data into memory locations, collections, arrays if you like, or records, an array of records, and then we can start playing with the data, going backwards and forwards and searching and analysing and doing whatever we need to do. Yeah? Remember though, it's a database system, and whatever we put into memory, if something's changed in the data at the other end, yeah, we have to consider that what we have in memory and what's in a table, do they match, and what damage are we doing, how are we programming? But that's a discussion for another subject and another time. We are here learning the mechanisms of how to store or how to create and use complex data types. So, collections. And here I'm going to talk about collections, I'm going to talk about V-arrays, and I'm going to talk about arrays. And I hope I don't confuse the issue, but when you walk away, if I do confuse you, you are learning about collections. That's all I'm teaching you, but I have to throw V-arrays and arrays in there to contrast and compare, yeah? But walk away thinking, oh yeah, I've learned about collections, but oh, hang on, let me read about them. Yeah, okay, I understand. According to the book, a collection is a data type that offers a way to store singly dimension arrays in PL/SQL. Collections used to be called PL/SQL tables. Listen, very good exam questions. Collections used to be called PL/SQL tables. Yeah? Not a table as in a database, PL/SQL tables. A collection is Oracle's ways of implementing arrays into its programming language. Not so much arrays, because arrays are fixed size. Collections are variable sizes. It's difficult to do serious programming without a data structure that allows you to store large amounts of data in a form of an array. I use this word array too freely. I should be really using collections, but I use the word array because I figure you guys are more familiar with the word array. So let me ask the question. Do you know what an array is?
Yes.
Everybody in the class knows what an array is? Yes? Yes? So, you know, you're storing an array from 1 to 100 and you've got all these different things and you can go backwards and forwards and you're storing things in memory. It's not an array because by an array you define of a set size. Initially you declare an array of 100 elements, whether it's two-dimensional or one-dimensional, but an array is something of a fixed size. So you might define 100 elements, but you might only use 10. But you're using the space of 100 elements. The reason a collection is different is that you index a collection by just creating new elements as need be. Now, in an array, you know that if you define an array of 100 elements, you refer to the array brackets 99 as the 99th element. And an array bracket 5, you're referring to the 5th element in the array. So you should then know that between element 1 to 100, that's occupying space in memory, yeah? Remember that as we talk about collections. Once collections are made, they are random. Here are some of the reasons that collections are useful. Once they're loaded into memory, they allow random and bidirectional access to any row in a set. Improve performance by allowing you to store lookup information into memory and to cache frequently used database values. Keep track and return to elements that are selected for special treatment. Associative arrays is the one that we're looking at. So collections, PLSQL tables, associative arrays. 3 things that mean exactly the same thing. So if you were to Google associative arrays Oracle, they'll tell you a story. If you were to Google collections Oracle, they'll tell you the same story. If you were to Google PLSQL tables, it's the old version of associative arrays or collections. Same thing. It's just the names changed over the years. Nowadays they're called collections. When I was working with this stuff, they were called associative arrays. Yeah? And before, yonks ago, to a PLSQL tables. So the name just changes. Associative arrays or collections is the way that what we're going to be talking about, nested tables and V arrays. Arrays and V arrays. Now, the difference is that when you create an array, you create so many elements, and I used an example from 100 elements, and then you're referring to the X element. But in memory, what happens is if you're referring to the 100th element, then you have 99 elements beforehand sitting in memory. Yeah, that's what a nested table or what an array is. An associative array or a collection, you can refer to the 20th element or the 100th element, but it could be only the single record. It doesn't need to occupy 100 elements. It's just the index that's being stored. So we're using the index pointer, the index number, as the way to get access into that record. So we travel. In one of your subjects, you would have done something called linked lists. You would have learned about linked lists, did you? You know where you're traversing through a linked list? This is what we're talking about. This is equivalent to a linked list where you have the next and previous. Next and previous. An array, very similar, but you're pointing to a particular element. And if you have 100 elements, basically you're storing 100 elements. 99 could be empty, and the 100th could occupy some value, but if you want to store something in the 100th element, you have to have 99 beforehand. A collection, you're creating a record, and you're just putting an index pointer in there. And you're just adding to the collection to let the collection grow. And the number, the index pointer, has no notion of how big the memory location is. That's basically the difference. And V array or variable arrays is you're specifying certain elements, but you don't have to store data in. Anyway, I'm sort of a little bit vague on these sort of things, so I'm not going to bother with it. You're free to have a look at it yourself, but you've got nested tables or arrays, V arrays, associative arrays or collections. We are talking about collections. Okay, now, the best way to solve this, or to skin this cat, is to just basically get in there and show you how this stuff works, and then with a little bit of luck the penny will drop, because we've just spent the last 15-20 minutes talking about records. So you understand what records are. Created from tables, created from your own data, user-defined records, and from cursors and tables and so on. In order to create a collection, we need to go through 5-6 steps. Step number 1, we need to create a record. We need to create a type of a record. And in that record, user-defined whatever you want to. However, whatever we've discussed the last 15-20 minutes ago, you create a record. And that record can have as many elements as you like. User-defined and of type. So, you can have a row type in here, which is 3-dimensional array, but you're creating a type of a record just like before. Step number 2, you need to create a second type. And this time, you're creating a type of table. Type, give it a name, is table of this type, of the type record, indexed by binary integer. This is important because you're specifying that the way that you're going to index an element of your collection is through a number. If I remember, I'll come back and talk about, this binary integer. But the key word binary underscore integer is basically you're saying binary integer means there's not a negative number. They're all positive numbers. One type, two types. Two types have to be created first. The record has to be created because in the second type you are creating a table of this type, of the type of record. So type, the name, is a table of records. In essence, indexed by binary integer. You must put this index by binary underscore integer. Your variable declarations, we have a collection now of type this. So we have a record, with all the elements that are in there. We're now saying I'm going to create a collection of that record type, but it's going to be a table. And the way I'm going to index it is through a binary integer, through a number. Number 3, type 1, type 2. Now we create a variable of the second type, which is a table of this type of records. Variable. We have a cursor, open the cursor, loop, fetch CX into. Now, when I say index by binary integer, the way that we create, or the way we index an element is, so we have a cursor, we're fetching through, we're creating a column, we're fetching a cursor, which is a select statement, into this variable, which is this variable here, bracket, index pointer. Counter is somewhere, counter is there, number, v index base is 1, so I'm setting it as 1. I could set that to 100. I could set that to 1,000, as long as it's a number, a binary integer, and then the way that I refer to this thing is I'm saying this collection at the location, in this case it's 1, I want you to store the data from the cursor into there, exit when not found, increment the counter by 1, and loop around. Collection 1, collection 2, collection 3, these are the elements that I'm storing, and I'm building my table in memory. Index by binary integer means that we're indexing by, this is how we're indexing it. Now again, I'm referring to this data type by its name. Abstract. I don't have to worry about individual elements, so I'm basically saying, okay, create this counter. When I'm using the elements, I can refer to the elements by the name of the variable, the index pointer dot attribute. What you're used to working with arrays, and obviously you work with arrays, is you're used to having the array name bracket number. My array bracket 10 bracket. My array bracket 100 close bracket. This one, the index is after the column name, but the elements are after that. So the pointer, the memory location, comes in after the element name, and then the attributes are after that. That's important to know. Now, I said before that I've set my value up to be 1. That makes sense. It's perfectly logical. I could set my value to be 100. Now, when I start populating my data and I put into the element or the collection index 100, that doesn't mean that I have 100 records. It's my first record, but its index is 100. Now, in an array, if I was referring to the 100th element, then I would have 99 before that. Yeah? Because I need to specify the size of an array. This is where a collection is different. The pointer is just a number that doesn't specify the size of your collection. So this thing might grow. There might be 100 records in there. There might be 10 records in there, but the numbers could be anywhere. Now, the example I showed you, you see I've got 1, 10, 11, 17, 20. That's how I'm pointing. So you could use an employee ID as the index pointer here. It doesn't have to be a sequential number. So for you to index a collection, the collection could be indexed by the primary key or whatever you've got, an employee number for argument's sake. So you can always go back to, depending on what you're processing, you can always go to the element of a particular employee by referring to its employee number rather than knowing which location it is in an array. Yeah, because in an array, to search for a particular employee ID, in my example, you would have to go, is that employee ID? Is this? Oh, okay, now I've got all the elements. Whereas in a collection, if you're depending on how you're indexing it and you're indexing it by some number that means something to you, you can go bang, straight into the record. Yeah? And then, of course, with a collection, it's akin to what you've learned in linked lists, which means you can go to the next one, you can traverse through, or you can go to the previous one. And in our tutorial, the tutorial that's sitting in for this week, you'll see that, what I do is I populate something and then I go back and then I go back and then I start populating, or, depending on what happens, I then fill in other columns. So I fill in a collection, and then I might go back and, change this, and then change this value, and change this value, and change this value, and change this value on some other attributes in my collection. Because I have the record, and then a collection is just a built-up of those collections, like a linked list, if you like. I talk about it as an array, but it's really a linked list. But it's easier to visualize as an array, without having the restrictions of a block of memory where every element has to have a number. So that's collections. And the way you refer to is collection, the brackets, index, dot, employee first name. If in this location in a record, for argument's sake, I don't know, can I change it? No, I don't think I can. Let's say I create something of an employee percentage row type, which means then I have a record, but with some depth. Like for each record, I've got other values there. The way that I would refer, so an employee might be, I might have an employee number or employee ID, and then I might have whatever the attribute is, then I might have an employee row type. So I have a collection, I have an attribute, then I have an attribute to an attribute. It's just dot notation, dot, 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 however many elements you have. So collection, bracket index, dot, attribute, I'm pointing here but with a recording. So collection, index, dot, attribute. If the attribute has other attributes, dot, whatever that other attribute is. Dot, dot, dot notation. Yeah? So now this is where you start going, whoa. Yeah? And in maybe 2 or 3 or 4 years, if you are lucky enough to work in an environment where they foster this sort of stuff, you'll be amazed at some of the things you'll build. very, your program becomes abstract, it becomes tight, then you start understanding, and that's when you start becoming a very good developer. Problem is that you then get a very good understanding of your system, but other people then have to keep up with you to try to understand, because it is abstract. Unless you understand, where the handles are to grip it and then start having a look and start shaking it and seeing what's happening. But this is the way it works. And here is an example. So this is my record, employee number. So a row is a record, and then what we do is we create a collection, which is create a type, which is a collection of these records, one after another, and then we give it a number, or we index it by the number. So a collection bracket 5, close bracket dot, employee last name will be referring to this. So generally what you'll see is we build a memory location, and then we go backwards and forwards through these elements, through these index pointers, or previous and next, and depending on what you're doing. Accessing the fields takes the following form: collection bracket index dot attribute. If there's an attribute to your attribute, then attribute dot attribute to. Example, col employee list, the second element dot employee number. And again, with arrays, and different languages are different, but do we have the 0 element, or don't we have a 0 element in an array? So different languages, in some languages you have a 0 element, in some you don't. Often what the programmers will do is they'll just go through and start from 1 to whatever the highest number is and ignore 0. And then somebody will say, but you're wasting a memory element, whatever. With collections, there's no such concept of elements 1 to 3. It's just an element as in a linked list, and you index it by a number. That doesn't mean it's the number in the location of... In a memory location, is just an index number. And then you write your program, basically however you do it, to control that. One of the other things that you can do, this index by binary integer, and I don't suggest you try this because there's something you do and I've completely forgot what it was, but you can index it by a varchar. So I could turn around and I could create in my index things like months of a year, January, February, March, April, May. I could index it to days of the week. If I index by number, if I'm talking about a year, I can still do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 1 to 7, but you can also index it by name. So then when you're referring to something, you go through, index January or index Smith, or you can index by name, and that adds a little bit of flavor to your code as well. But for all intents and purposes, for you, index by binary integer. But if you're reading about it and you try to understand it a little bit more, you'll see that it might come up and talk about varchars as well. And this is something that I would strongly recommend. These data types in whatever language. Your Java, you all love Java or whatever, there will be complex data types in Java as well. You will be wise to learn to use these things. It will serve you well. In PLSQL, collections, very good, particularly if you need to process a lot of data quickly. But remember, you are working in a database environment, and whatever you load into the database and you're working, into memory, you have to remember what are the chances of that data being changed at the table end, because ultimately it has to go back into the table. Now you might have to loop back through and just write everything back, or update, or check has the data changed and update and change this sort of stuff, but is anything else changing it on the other side? So potentially it could be very dangerous. In my sample that I gave you when I was working for Origin Energy, I had to create contracts every week, and there were new contracts. So I basically had to build a list of contracts, and we were buying electricity off the snowy mountains, the Snowies. they let the water out, and then of course every time the price of electricity goes high, what they would do is, they would say, okay, we're willing to sell if the price reaches such and such a level. Well, if we wanted to buy it, we would get into contractual arrangement to them. So there'll be contracts in there because computers work on these things. So I had to build contracts for the coming month or week or whatever it was. If the price is this, then we're going to buy this. If the price is that, we're going to buy this. If the price is this, then we're going to buy this. If the price, it just goes on and on and on. So this was a very good exercise for me. Like everything else, curses and everything, collections have attributes. You can obtain information and modify the contents of collections using built-in functions and procedures known as collection methods. We already have seen one in action. Remember, DBMS output, the counter is, and then you have, this is somewhere in here, obviously we must have had, count, but you're using the collection attribute is count. How many elements are there in a collection? Delete the number, removes the element without arguments, so you can remove elements from a collection. Exists, determine if a specified element exists. Extend, not related to associative arrays, but used for V arrays. Not an array, a variable array where you're building something and then so you can extend an array. Go to the first and go to the last. So if you're processing through your collections, you might want to go back one, forward one. You might want to go to the first. You might want to go to the last. Prior, next. Trim removes an element from an end of a nested table or V array. So again, some of these methods and operations are not relevant to collections. Some of them are relevant to V arrays, and some of them are relevant to array. It's enough for me that you just know the names, and that there are differences between arrays, V arrays, but we are talking about collections.
So what does the trim do?
So trim, I think, just gets rid of the last one. Removes the element from end of a nested table or V array. So if you've got an array and you want to trim one off, you basically say trim and it removes the last element. Yeah, the point is that there's some methods that you can operate on, so you don't have to manually do it. Records and collections, so we're talking about records, and then we spoke about collections, are a wonderful programming tool that simplifies your programming tasks, makes your code more readable and maintainable, and encourages the production of professional code, in my opinion. Chapter 11 in a book has that information. You can also discover that there are 3 different collections: associative array, V arrays, nested table. Laurie, these are my thoughts and something that I've mentioned to you already. As a database programmer, you should make it, and the term is, you should make it your mission in life. As a programmer, your mission in life is to be able to program with records and collections just as efficiently as you speak your native language. I didn't say English. As you speak and you converse with people in your native language. As a programmer, you should work to make yourself just as efficient at programming with these elements as you are efficient in speaking to your counterparts in your native language. As a programmer, this should be your mission in life. I don't care what language. I don't give a damn. But understand the complex data types and how to build them, and then depending on what environment you end up parachuting and landing when you finally get your job, that will determine, where you're going to go and what you're going to do. Understand, and one of the first things you should do in the back of your mind, okay, I understand where I am. What are the complex data types of the language that I'm using? And let me now show these guys what I'm all about. That's Laurie's thoughts. That's my advice to you guys. You will make yourself a very, very good developer, and you will make yourself, you'll understand your craft, and you'll impress a lot of people. That's what it's all about, isn't it? As long as somebody goes, oh, God, how did he do that?